Good. Okay.
Okay.
Hello, everyone. Thank you for joining DataCon LA 2021. Welcome to Data Infrastructure and Security. My name is Hestia, your host, and your co-host today is Idris. We will be moderating the chat and Q&A for you during the session. Today we have our guest, Searle. He is the VP Sales and Licensing for XSOC. And without further ado, please, you can start.
Thanks so much. Yes, this is Searle with XSOC Corporation. Today we'll be talking about cryptography and a few aspects of cryptography, specifically strength, speed, efficiency, those kind of things that are extremely important to IT and OT professionals. So the planned speakers today were my boss, Richard, and our CIO and Chief Architect, Michael. They are both held up in an extremely important engineering task today, but I'm happy to fill in. In fact, I do most of these presentations, and I wrote about 80% of this one, so you'll still be well-versed and good speaker for you. In terms of why we are in the market, there's a few things. Right now in the cryptography space, there is a lot of time, money, effort spent on post-breach activities. Can we detect it? How long did it take to detect it? Some in the resiliency space. But in terms of actual things that protect data, as in the first two pieces of the NIST cybersecurity architecture that we all go by, the identify and protect space, the protect space is actually where we're at. So in terms of what we do, we provide very high quality, premium grade encryption and cryptography that can be used by professionals, integrators, enterprise environments, the government, the military, to strengthen their encryption, make it faster, make it more efficient. And then in terms of time here, just going by the deck, time is now, unfortunately. We all had a pretty evident clock when Y2K came. That affected the whole world, and we all did a pretty good job of mitigating it. And there were very few instances of anything that happened with Y2K. However, there's a quantum version of that, and it's not going to be as well known. In fact, just about every major billion-dollar company you can think of, including just about every government, is investing heavily in quantum computing. And there's a lot of very good reasons for quantum computing to exist. It speeds up many, many things that'll make humanity better. Testing, a lot of biomedical uses for it. The downside, though, is it's also a very useful tool for breaking encryption. And we've known this for a while now, and it's become more popular in the media, that the practice, or we'll call it attack vector, of harvesting data, or harvest and decrypt, they call it, has been going on for some time now, especially amongst our nation state adversaries. So this practice of collecting encrypted data so that it can be broken with a quantum computer is unfortunately affecting everyone right now. So when we say quantum safe, our cryptography and encryption algorithms actually are quantum safe. The key length is considerably longer, exponentially longer than what's being used today, and actually will go well into the future because it's actually variable. And then in terms of the space we're in, again, this affects just about every industry: banking, finance, legal, healthcare, insurance, manufacturing, utilities, telco, governments, just about every single sector is affected by the need for better cryptography. And in terms of where specifically our product fits, this is just a chart we put together real quick, but you can see from the industries there, the OEM, software, hardware, and then software, the biggest names, the biggest pieces of security in this space are all growing by double digits. and substantially over just the next 4 or 5 years. And what will be driving this is, unfortunately, that the cyber criminals and cyber attackers are still very successful. And what will actually drive our business is this need for better cryptography and encryption. And then just some specific examples that we've already come across and been brought into smart buildings, right? So when you think smart, you think connected, maybe connected to your device, automation, things that make things faster, easier, save us all time. Right now, if you look at smart buildings, they may be very smart in terms of the automation, the AC, all the video, everything that goes into a smart building. But they are at risk of being hacked. Same with software right now. Data breaches, these harvesting attacks, especially ransomware. I hate to even bring up ransomware, but it's so common right now. In fact, they say there's a data breach every 39 seconds, I think, and there's a ransomware attack every 11 seconds. And we can actually mitigate a substantial portion of ransomware. And then going on to device security, most of the industry right now is focused on IoT devices, right? The Internet of Things. Anything that is connected that, again, can be anything from a Google Home device to a sensor on the outside of a manufacturing plant, to, smart watches, healthcare appliances. But what all these things lack is strong security. And especially IoT devices generate phenomenal amounts of data. And right now there's, plans in the works to try and come out with lighter, faster cryptography to protect these devices. That's what we actually have today. So just going down the right side of this slide, smart buildings that use our cryptography, the data isn't exposed anymore. It's absolutely encrypted. In terms of software, the OEMs, the hardware vendors, the camera manufacturers, the IIoT manufacturers in that space that protect our critical infrastructure, everything from oil pipelines to trains to water, all that fits into the critical infrastructure space. And because of the age and because of how restrictive the protocols that equipment use, it takes a very specific kind of encryption to work in that environment, and we do. And then in terms of, again, the IoT devices, our goal would be absolutely to be integrated by every IoT, IIoT, IoBT manufacturer so that all that data can be protected. And then in terms of specific products, I'll start with the first of our 4 pillars, which is our Exocryptosystem. So this crypto system is called a crypto system rather than an algorithm or a cipher because it actually integrates a few things that aren't in normal cryptography. It actually has a number of modes of operation that allow it to be optimized. And I will back up one quick sec. So the acronym for our company, XSOC, stands for Extensible, Secure, Optimized Cryptography. And when I go through our products and platforms here, you'll see the extensibility, security, and optimization that we built into all of our products and platforms. But this crypto system actually fits in a number of different categories. What we use on the internet today is called asymmetric encryption. What you use typically on your devices, your big data centers, in the cloud is called symmetric cryptography. And there's a reason both of those have had their place in history so far. But we believe symmetric cryptography, if optimized and highly secure, can be used everywhere. And in fact, we've made it so light, so fast, so efficient, it can be used everywhere. That's the really exciting thing today for the viewers and the listeners and then all the manufacturers we're working with. And then just a quick chart here, just to compare for those who maybe aren't as geeky in encryption as I am, but just to point out the other 2 probably most well-known encryption algorithms out there, AES and ChaCha. You can see strength-wise, we start at what is a quantum safe strength, which is 512-bit. AES tops out at 256. So does ChaCha. And in the quantum realm, that is not overly secure anymore. In fact, we've got pages and pages of industry leaders from all the major software manufacturers, people who work at NIST. The current CEO of IBM said, move to quantum. The CTO of Amazon wears a big shirt at meetings that says encrypt everything. So this isn't new. We're kind of in line with how the industry is moving to something much stronger. However, the lightweight and the latency is typically what keeps IT folks from using cryptography. They realize its benefits. But again, if you have a lock the size of a boat anchor and you want to put that in your network, you know for a fact there's no coming back from that. I've spent 20 years in the channel and with manufacturers, EMC, selling Cisco, selling a lot of security over the last 10 years. And as soon as you encrypt things, there's usually a 20 to 40% hit to your compute and overall network latency. And that is just something most IT folks don't want to do. In the latest Ponemon report, and it has actually been saying for years, the IT folks make the majority of the decisions whether or not to use encryption. So if it's too slow to use, even though it's really great to have, people still don't use it. But then still just going down this chart, again, our extensibility to be used just about everywhere because it's so small, so lightweight, so fast. And then our attack resistance. The attack resistance of AES has come into question, especially side channel attacks. So again, great place to look at the Exocryptosystem. So what goes along with symmetric cryptography is you create a single key, which is different than asymmetric cryptography where there's pairs of keys. So really, the only thing that's kept symmetric cryptography from being used almost everywhere is how do I move that key efficiently and securely from me, the sender, to you, the recipient. So we've actually addressed this issue as well. So we didn't just take on half the problem and say, let's make better encryption. We also looked at, okay, what does it take for that encryption to work ubiquitously everywhere? And that's where Socket comes in. And it's a way to move both in air-gapped environments, which are, used to be OT critical infrastructure, right? That was what they called their environment that protected them from the outside world. It wasn't internet connected, but it was just connected inside their network. So again, kind of like the old Mission Impossible movie, Tom Cruise lowers himself into the room. There's no connectivity. Since then, though, we've come to realize that even critical infrastructure is still connected to their IT side of the house. So they are now much more vulnerable to things that affect IT networks, which again has to be addressed. So if you can use now very lightweight, very strong encryption, and you have a way to move those keys very efficiently without having pairs of keys, which actually are quantum vulnerable, I mean, that's well-known stated fact too, now you've really got the whole solution. Beyond that, so an extension of Socket is also our ability to do this same key exchange, but using DHT networks. So much the same way that, we shared music in the old days via distributed hash table networks, we can actually use that key exchange technology over DHT as well, which again, for future purposes would make an excellent platform for social media and places where privacy and censorship might come in. And then really just the next step too of moving that key. Today, you would still have to move that key across existing protocols, right? Like HTTP or, most used protocol, probably everybody's familiar with, is FTP. And they've got secure versions of that, but those still rely on the same cryptography that I pointed out when I highlighted XSOC. Those aren't going to be strong forever, and they're not very fast. So really, our move to make an encrypted protocol, what we call EVP, came about from a government slash military example where we had to move encrypted data over radios. And again, we're not talking high bandwidth. We're talking very, very low bandwidth, sometimes low technology. And so it just made sense for us to just kind of extend our product suite and create a protocol that was also extremely efficient. And it's actually got a feature called proactive flow control, which actually intelligently monitors on the fly the latency between point A and point B. So whether it's a broadcast or a selected unicast or multicast environment, we're extremely efficient there. And then here's just a quick competitive analysis too on EBP. Compared to UDP, which again is very fast, but not 100% reliable. TCP, extremely reliable, not very fast, not very flexible. One of our competitors has a customized protocol that does somewhat what we do. But I'd like to think, again, because we're putting out tools and platforms for developers and folks to integrate, not a giant behemoth product like some of our competitors have, we're much more agile in being able to bring that to market. And then again, and just in terms of what the folks are saying out there, performance and latency, most important feature of cryptography. Folks moving data to the cloud happens all the time. And unfortunately, we read a lot about what happens in misconfigured cloud. But again, if you read most of what's out there, especially from an IT perspective, everyone will tell you to encrypt your data before you move it to the cloud. In fact, we gave a presentation a while back, and we did some research on all the major cloud platforms and their terms of service and their user agreement. And very clearly, and this isn't hidden. I mean, you can absolutely search for the word encryption in all of these documents. It very clearly delineates that they are not responsible for the security of your data. You are. So again, that's where we come into play. We give you the tools to protect your data before you move it to the cloud. And then again, just in the bottom 5 here, what the drivers were, right? Protecting the information, protecting your IP, obviously guarding your environment against threats, the regulatory, and the liability. And then again, just here's a little quick summary on our 4 products and how they work together. And then if we have, I think we have some time left over now for Q&A. I'd be happy to answer.
So far, there hasn't been any questions. The session will go all the way to 3 o'clock. If anyone have any questions, you can stay in and see if there's anyone that has any questions.
Sure.
Thank you again for coming out. And
yeah, I'm not seeing any questions either. Thank you, Ian. This was really good.
Okay. Yeah, I'll hang around if somebody jumps in here.
Yes, yeah, that'd be great. Yeah, you ended earlier than scheduled, which is fine. And I hope Richard and Michael is okay. I heard that they got sick, so.
Yeah. Yeah, it's unfortunately going around. While big things are going on too. So probably as soon as this is over, I'll check in on everybody and go from there.
Right. So are you only the VP of sales there? Do you do other things? Are you a developer as well?
Not a developer, no. I will absolutely leave the developing to the folks that are, experts at that. My background is IT specifically. So very early on in my career, I realized I really loved IT. I loved technology. I loved, how it could speed up information, how we could use information. Obviously, from a sales perspective, it's extremely useful. But no, I've worked for storage companies, network manufacturers, kind of migrated towards security because that seemed to be kind of the greatest use case for all your technology, right? Networking was great. It's the plumbing of everything. Storage is great. That's where you put all of it. But at the end of the day, you've still got, a mountain of extremely valuable information that has to be protected. And I saw more often that our customers were spending a lot of money, time, money, and effort in things that didn't actually protect data. It's all mitigating after the fact. And even the point I was going to make on ransomware is if you look at actually the transaction of ransomware, and I've had more than a few, unfortunately, friends, colleagues, and customers tell me about this. A ransomer's goal is to sell the data, use the data, and or ransom it back to you. So if the data is so strongly encrypted that even them saving it for 20, 50, 100 years doesn't work, it has no sale value now, and it has no use. So effectively, you've mitigated 2/3 of what a ransom attacker might do. Obviously, they can still ransom it back to you, but again, that goes back to your architecture, your policies, procedures. If you've got adequate offline backups, if you've done your homework, you've identified where your data is, and you're able to restore, then really you're in a much better spot by spending money on encryption than you are on a lot of these post-breach remediation and services.
It seems that so I'm assuming that since this mainly is more for security, you guys work a lot with governments and banking, I suppose.
Yeah, they're definitely two of the big users. Obviously, everything from all of our financial, even Bitcoin uses a very obscure form of encryption. But in terms of, the most valuable data, healthcare, company IP, enterprise IP is probably just as valuable as anything else out there too. And if you think of almost every business has their secret sauce that they should be protecting. It's easy to point out the Facebooks, and companies that use our data day in and day out to sell us. But I've called on a number of global enterprise companies in just the Orange County area where I've been central to for many years, and their company IP is extremely valuable. Everything from life science companies to financial investment companies that have their financial algorithms that they make trades on. Pharmaceutical companies spend millions to protect what goes in there. Proprietary formulas. Oddly enough, even marijuana growers treat their data much like a biomedical company would. And, we've had conversations with them in the past, and they said, if somebody got a hold of this proprietary formula that we both sell and white label, we'd be out of business, completely out of business. And that's, a multi-billion-dollar industry now. The other thing that's happening all the time is streaming media, right? As we've all stayed home with COVID over the last year and a half, much more reliance on remote workers. A lot of video conferencing going on. And if we consider the fact that, the keys used for video conferencing are very infrequently changed. In fact, we looked at one of the major providers, and if you kept on your XYZ, I won't say the name, video conferencing provider all day long, it used the same key all day long. So very early on, I was able to find out the key that they were using. I could have easily recorded all of the transactions that went on in a given day. And again, think of all the confidential and proprietary information that gets shared on a big conference call these days. So again, that's a really unique case for video conferencing, streaming media. All that could be protected much stronger, much faster than what's being used today.
Yeah, that's why companies like XYZ video companies get hackers a lot. I'm in school virtually, and they often tell me that they have random hackers attending classes that's not in the
not enrolled.
Yeah, not enrolled, and they would send weird things. And I'm just like, what? That's crazy. That's
yeah.
So with all the virtual, I think the virtual world has been fast-tracked through COVID entirely. But what do you see in the future that's like, what do you foresee that's not in the slide in the future?
Yeah, so back to the threat of quantum computing, it's easy to say, that's in the distance. But if we look at where folks are spending money right now, globally, digital transformation and security and maybe artificial intelligence have got to be in the top three. Artificial intelligence, again, it's just going to speed up and automate from our perspective, hacking and bad things. That's one use case for it. But quantum computing, because everybody is investing in it, and this isn't Y2K, if China, if North Korea, if Russia is able to make advances in quantum computing, speed things up, they don't have to notify the world, and they could very easily use it for, bad purposes. So that's a threat, unfortunately, that's imminent and has been going on. And the whole data harvesting attack is something we've been bringing up to folks for a while, but it seems like it's gotten a lot more media attention now. The government's recognized that China's been doing this for years, and we would hate for any government information that will still be valuable in 5 years, 3 years, 7 years, whatever it takes, to be in the hands of our nation state enemies. So right now, I think there's a huge push to start using stronger, faster encryption. The other thing I didn't point out probably in the deck is that the government is making strides in that direction, right? They've had, NIST has had a contest going on for lightweight encryption, meaning encryption that is small enough, efficient enough, fast enough to work on very, very low end, inexpensive. I mean, even DARPA used the word cheap hardware. But that still isn't concluded yet. And unfortunately, the strength of most of the encryption they're looking at is 128-bit or less. Mm-hmm. So again, you've addressed part of the problem. You've come out with something very lightweight, very efficient, something that can not consume too much battery power or electrical power, but it's not strong enough. And then if you look at AES right now, there is no move to replace that. There are still folks in the government that will say that's strong enough. And there's still a lot of folks academically and in industry that says if you're keeping your data more than 5-10 years, move it to something stronger immediately. And then you look at what protects, internet transactions, which is PKI, public key infrastructure, uses asymmetric encryption, those key pairs. It's not even a debate. They've said quantum computing will break that in minutes. And that's not a couple people. That's everybody recognizes that. So there's another government contest going on right now to try and provide alternatives to what they're using today. But, we really think we've got the best of all worlds, really. Really, really small, really lightweight, and really strong, which typically the two of those haven't been well married in the past. It's either strong and slow and, bogs down your network, or it's really light and fast, but not strong enough. And then how to move the keys, right? Our socket, our WAN socket product could actually work with AES today. You could presumably use that almost anywhere now as a more secure form of moving keys anywhere.
Idris is actually talking on Sunday on JSON. Correct, Idris?
That's right. Yeah. So
do you
session is based on
moving monolithic data platform? Oh no, it's on how to get real-time insight from your JSON data. Do you have any questions for Ian?
Sure. Yeah. Actually, I was
WebSockets and security, data security.
Yeah.
Especially if you're doing JSON, just not quite.
Yeah. So can you hear me well?
Yes.
Okay. My question, Ian, nice to meet you. I'm a product manager at College-Based Analytics.
Nice to meet you.
Another question. Nice to meet you, Ian. Question is, so you were presenting, what kind of encryption does your XSOC CORP have for transactions which are going on the API level? Can you encrypt API encryptions as well as the data? We are a NoSQL database company, so we have a lot of tons of data, privacy data, etc. going there. What role does your product play there?
So it's a great question, and that's actually come up recently with some of our customer base that asked me about unstructured data.
Mm-hmm.
And I said, yeah. In fact, I started doing research on how much unstructured data, and even oddly enough, one of my very good friends worked for MapR for years, now works for Google, and used to bring me to big data conferences in LA that Subhash D'Souza was heading up there too. So I'd been peripherally involved in some big data in the past, but in terms of how to encrypt that, I'd say, yeah, our symmetric streaming encryption is going to be the fastest, strongest, most efficient way to do it by far. And the example that came up recently was a financial institution that has a significant amount of unstructured data. And I don't know exactly where it is yet. I haven't gotten that far into the conversation. It could be anything from agent recordings of customer service calls. It could be video footage from all of their locations globally. I'm not quite sure what format it's in, but I think the ability to rapidly encrypt that, especially since they're obviously housing it in a public cloud, would be extremely valuable.
Yeah, if you don't mind, if you mind share, if I share my screen just to give you an example of
sure.
What an example of a.
Do I need to stop sharing then?
I don't know. It would be.
Yes, you can stop share.
Okay.
Yeah, let me see if I can share this real quick. So can you see my screen?
Yes.
It might be a little crazy, but yeah, this is all faked up example. This is our tool, the workbench. But the data what we stored is in unstructured format. So as you can see, this is a classic e-commerce example.
I can't see your screen yet. I'm sorry.
Oh, okay. can't see my screen yet. Can you see my screen?
I can see your screen.
Can you see my
Ian,
LinkedIn screen?
is it slow or do you not see
No,
anything?
I just only see my presentation still. I don't know.
Oh, you can leave from your presentation.
Oh, there we go.
uncheck
Okay.
Presentation. Can you see it now?
Yep.
Awesome. Okay. You can go, Idris.
Yeah, just to give an example, basically, this is.
And you can talk louder.
Yeah, sorry. So as you can see, basically, is an example of a data being stored in unstructured data, just like JSON format, or you call JavaScript object notation format, which is more of key value pairs. We're talking about key value pairs. So this is an example what you would see, for example. This is a classic e-commerce example. You have billing, this address, country, so on and so forth, and then within that you would have like nested array of data. In the typical relational database world, you would have a table, you would have another one-to-many, but in an unstructured way, it allows you the flexibility to create multiple lines within one order. So question here, going back to security, is like these data is all sitting on the cloud. It's on Amazon servers, right? So encryption, when the data gets queried by, this is from our workbench, you may get queried over an API or queried over from a custom application or pretty sensitive data, right? This is becoming a big request where they want, as the data is being session data from LinkedIn or Apple or all of these devices are getting to be securely transported. Make sense? So that was just want to give you an example of what this kind of data world, unstructured data world kind of looks like, if you will.
Yeah, I think our EBP product would probably address that. We created it specifically to move symmetric keys around, but quickly we figured that it can be an actual very viable competitor to like a FileZilla or an IBM Aspera that uses their FAST protocol. And I believe ours is more efficient, faster, and uses strong encryption. So I think that could be extremely useful. We've also done presentations. We did one in the past at an Oracle event where our CIO, again, who wasn't well today, but presented on the fact that we could actually encrypt data down to the row level, and gave an example of a full 3-tier web architecture that he's built that actually encrypts every transaction from the presentation to the middle to the database layer back and forth. So that's how fast it is.
I used to work for Oracle, so I can relate to that.
Yeah. When he's brought that up in customer presentations, people are fairly amazed. And really, you can do that? Well, yeah. I guess if most people's perception of encryption is what AES is, and we've had very, very, very frank conversations with backup companies. One that starts with a V. And I said, when they hit the compliance encryption button, when they do a backup to the cloud, how much latency does that pose? And he gets 20%, right off the top, 20%. And I'm like, ouch. And he goes, we don't bring that up very often. That isn't something we like to talk about because it's such a boat anchor. So it's really kind of changing people's perception that, strength is critically important, but speed is the reason people don't use it. So if we're fast enough, and strong, then, that's the best case. And I think for folks like you too, that are obviously adept, and, JSON is a term that, again, our architect throws around a lot. So he's very, very, very familiar with your environment. We can give trial versions of the encryption that show the different modes of operation it can be used in. and you can go ahead and start playing with it and run your own tests and see how fast it is. Because that's usually the easiest selling point for us is, hey, go ahead and try it out. It's literally two lines of code, right? The encrypt and the decrypt part, and then the mode of operation you use it with.
Right. Makes sense. Yeah, we have, if you can connect on maybe on LinkedIn, I can connect you my product security person who's in charge for the whole server.
Yeah.
Side, and then go from there. Sounds good. Thank you, Ian.
Absolutely.
Thank you, Ian, and thank you for your presentation, and the attendees for. If you have any questions and interactions, you can contact Ian, and you can contact the speaker directly if there's any further questions regarding this topic. Please provide your feedback using the form provided in the chat box. Thank you again for everyone joining today's presentation, Cryptographic Speed, Reliability, and Security. I hope you guys can gain some insights from the session and have a wonderful day. And thank you for being part of this year's DataCon LA. Have a good day, guys.
Have a nice weekend.
You too.
Bye.